Welcome back. In this second course, we'll understand what schema compatibility is and how it applies to other schemas. As we saw in the previous video, subject schemas are versioned in the schema registry. When trying to add a new schema version, the registry will check the new version against the existing ones and will decide if this new version is compatible with the rest. Compatibility exists to ensure that you don't have to update at the same time all the different applications exchanging data over a topic. It ensures that you can safely evolve your schema for some of them, while the other can still work just fine using a previous version of the schema. Depending on what guarantees you need, there are multiple ways to define compatibility. If we go into the control center to our user registrations topic under the schema tab, press this button here and then click on compatibility settings. We can set it either to none or one of the other six. When discussing compatibility, we have backward and forward and then a few variations from these. When you think of compatibility, you should always think of consumers first. And the reason behind it is that when a schema evolves, it is the consumers that are most likely to break. Producers just have to write some bytes into Kafka. They don't really depend on another application's view of the data model, whereas consumers have to fetch data from Kafka that was written there by someone else. So this is where schema evolution issues are likely to appear. If you think about consumers first when discussing compatibility, the concepts of backward and forward compatibility become intuitive. Let's start with backward compatibility. This is the default one, and it means that consumers using the new schema can read data written by producers using the latest registered schema. So it's called backward because the consumer has to be able to understand a previous or backward version of the data model. Again, the naming is from a consumer's perspective. So to reiterate, backward means that if you have two versions registered right now and you want to add a third, the registry will check whether consumers using version 3 will be able to deserialize messages published using version 2. When evolving your schema, if you want to update your consumers first, you should be enforcing backward compatibility. This means that backward compatible changes are deleting fields, since consumers with the new schema will simply ignore the deleted fields that are still being sent by producers with the previous version schema. Or we can add optional fields or fields that have a default value, because when you add an optional field, producers with the previous version will not know about the new field, but consumers with the new version can use the default value for the new field. Moving forward, we have transitive backwards. So this is like backward compatibility, but instead of comparing the new version just with the previous one, it will be compared with all the existing versions. So if we have two versions registered and we want to add a third, the registry will check it against both existing versions. Next, we have forward compatibility, where consumers using the latest registered schema can read data written by producers with the new schema. As the naming might also suggest, this is the reverse of backward compatibility. It's meant to be used when you need to update your producers first. And if you think about the naming from a consumer perspective, the name is again very intuitive. Consumers will need to keep working when given messages of a new version, a forward version. This means that if you want to evolve a schema in a forward compatible way, you can add fields, since consumers using the previous version won't know about these fields, so they can just ignore them. Or you can delete optional fields, because consumers using the previous version will use the default value for the deleted field, the one that your producers will no longer send. Then we have transitive forwards, so the same rules apply as for forward compatibility, but instead of comparing the new version just with the previous one, it will be compared with all the existing versions. Then we have full compatibility, where the new schema is both forward and backward compatible. Full compatibility gives you the flexibility to update consumers and producers in any order you want. And obviously, it's also the most restrictive in terms of what operations you can perform when evolving your schemas. since you can only add optional fields or delete optional fields. And finally, we have the transitive full compatibility mode, where you have full compatibility but against all versions. Alright, now that we went over the compatibility types, let's try to apply them in a few scenarios. In our GitHub repository, we have this file called Schema Evolution. If we look inside it, we have two exercises to solve. I suggest that you pause this video and try to solve them on your own, and then come back and verify your solutions. For the first exercise, we start from a user record, and we have to create 3 new versions to satisfy these requirements, all while maintaining backward compatibility. The second exercise is similar, but we start from a different schema and we have to maintain forward transitive compatibility. Pause the video here and try to solve this. We'll now go over the solutions. For the first exercise, we start from this simple user record, which has an ID, an email, and a name. For the first change, we need to add the user phone to our model. It will be represented as a simple string. Now, because we have to maintain backward compatibility, this means that consumers that will use this new version that we create will still have to work correctly with messages that were produced using the previous version. If we add a new field to our new version, this will not be populated by the producers that use the previous version because they don't know this new field exists. So we have to provide a default value for it. As you can see, that's what we did here. We made our phone number nullable and we assigned it a default value of null so that consumers can be able to handle its absence. For the second change, to meet compliance requirements, the system must now track whether the user has agreed to terms and conditions. If no information is available, we should assume they chose to not agree. So what we need is a Boolean flag with a default of false. This is pretty similar to the previous point, right? Only this time there is no need to make our agreed to terms field nullable, since we can already assign it a sensible default of false. And this is a change that is backward compatible because it represents adding an optional field. So the important thing to remember here is that optional does not mean nullable. It just means having a default value. It expresses that if it's missing from the payload, it can still be handled by consumers. Wonderful. Going to the third change, we move the name fields into a different model that encompasses more details about the users. We should delete this field from the user model. Again, this is a change that we can just implement with no worries. It's something that is backward compatible. Consumers that will use this new version will still very much be able to handle messages from the previous version by simply ignoring the deleted fields. Alright, going to exercise 2 now, where we start from an order record with an ID and a date and an amount, and we have to operate within forward transitive compatibility constraints. So for the first change, we were asked to introduce a payment method field, which is an enum. This is a forward compatible change out of the box. There is no need to make it optional because it's in a way similar to deleting a field in backward compatibility, right? Producers will use this new schema and will write the payment method in the message payload. Consumers with the previous version will simply ignore it. And then for the final point, the order amount will be streamed through our systems as part of a different data model. We want to remove it from our order model. This is a trickier one. We can't remove order amount from our schemas since we have to be forward compatible. If we remove the order amount, the new version producers will no longer send it, but the older version consumers will always expect a value for it since it's not an optional field. So what we can do for the first iteration is to make this field optional by providing a default. We can also flag this field as deprecated. We don't really have a smart way of doing this in AVSC files, but we can use the doc attribute. Now, we might jump the gun and think that since this is now optional, we could remove it in a future version. But it's really not that simple since we have to respect forward transitive compatibility. So as long as the first 2 versions are still registered, we will not be able to remove this field. Amazing! So now we have a decent understanding of Avro compatibility. We'll see each other in the next video.